Hello viewers, welcome to my channel. If you haven't yet subscribed to my channel, do subscribe and press the bell icon near the subscribe button so that you get the notifications of my latest videos. And do not forget to like and share the video. We'll be continuing this chapter, Light, Reflection and Refraction. It belongs to the chapter 1 of Physics and chapter 10 of NCERT. Our topic for today is spherical lenses. First, I'll be explaining you about the spherical lenses. Then we'll be going for some important terms related to spherical lenses. So, what is a spherical lens? Okay, I'll tell you what is a spherical lens first. It is a transparent material, which means you can see through it. It is a transparent material bound by two surfaces of which it can be either one or both the surfaces are spherical. A spherical lens is defined as a transparent material bound by two surfaces of which one or both the surfaces are spherical. Okay, and spherical lenses are of two types: convex lens and concave lens. Convex lens is a converging lens. Concave lens is a diverging lens. We will be studying about these lenses in detail in the further videos. So in these lenses, both the surfaces are spherical. Alright, both the surfaces form a part of the sphere. This is a portion of transparent glass bound by two spherical surfaces. These two lenses. Alright. Now let me show you how it is a part of a lens. I have been telling you, a part of a sphere. I have been telling you that these lenses form part of sphere. Just let me show you how it is part of sphere. I showed you that convex lens is like this, right? This is a convex lens or the converging lens. Now, I take two spheres. This is a convex lens. Now, I take two spheres like this. Okay, let me draw dotted lines. This is my first sphere. Then I take my second sphere like this. Both are spheres. Alright. Now I take only this portion. I take only this portion. Okay, and I don't want all these portions. This is how it forms part of two spheres. This forms your convex lens. Alright, it is being formed from two spheres. It is a part of two spheres. This was your convex lens. Now concave lens. How is a concave lens? Concave lens, let me draw two spheres again. This is my first sphere. Then I take my second sphere like this. This is my second sphere. I take only this part. I do not want the other parts. This is how a concave lens is formed. Concave lens or divergent lens. Okay, concave lens. And here, let me show you the convex lens. Convex lens was like this. Convex lens or converging lens. Here, diverging lens. So, convex lens is thicker in the middle. See, it's thicker in these parts, whereas thinner at the ends. See, it becomes thinner and thinner at the ends. Here it becomes thinner. Again, here it becomes thinner. This is a convex lens. In case of concave lens, it is thinner in the middle part and slowly becomes thicker at the ends. Alright. So this was about convex and concave lens or converging and diverging lenses. Now let me go for some important terms related to spherical lenses. Some terms. So the first term which I would like to teach you is about the optical center. Okay, optical center or optic center, whatever. It is either optical center or optic center. I take it as optic center. Optic center is the central point of the lens. Okay, now let me take a convex lens and show you first. This is the convex lens. Okay, this point is the center of this lens, of this convex lens. So this point is known as the optic center. It is represented by the letter capital O. Now with a concave lens, this is a concave lens. Then this is the center of the concave lens. This center point of this concave lens is known as its optic center O. Alright. This was about the optic center. Then the second one is aperture. Aperture. It is the effective diameter of the circular outline of a spherical lens in which the refraction takes place. Since it is lens and lenses are transparent medium, right? So through transparent medium, light can refract. So definitely refraction is going to take place in lenses. So aperture is the effective diameter of the circular outline of a spherical lens in which refraction takes place. Refraction of light takes place. That means this circular outline of the spherical part, this outline, okay, through these areas refraction takes place, right? So this is known as aperture. Again over here in concave lens, this circular outline, through these areas only the refraction of light takes place. The circular border, okay, circular, the effective diameter of the circular outline is known as your aperture. Next, I'll go for the center of curvature. Let me show you how it is actually formed in the lenses. First of all, I take a convex lens. Let me go with the convex lens first. Then I'll teach you with the concave lens. Alright. This is the convex lens. Convex lens. How is the sphere formed? It is like something like this, and this is this sphere, and over here the sphere is something like this. Alright, both are spheres. Now spheres have a center, right? Each sphere will definitely have a center. Without center, how can you draw a sphere? That's not possible, right? So definitely this sphere has its own center. This is the center, okay, and this sphere has its own center. This, just imagine this to be a center because we do not have exact measurements. Let's take just approximate measurements. This is the center. Now this lens is going to have two centers, C1, C2. Alright, now I erase this dotted lines. So lenses have two centers, C1 and C2. This is optic center. Alright, now principal axis is the imaginary straight line that passes through C1 optic center, C2. This is your principal axis, okay? Principal axis. Alright, now principal focus. Now how would I define principal focus? Now this was about the convex lens. Similarly for concave lens also it will be like that. Two spheres, then there would be two center of curvatures. If you want, let me just draw and show you for concave lenses also, so that you can understand even more better. You can get a clear-cut idea of the concept. This is the spherical. This is spherical lens. This is the sphere out of which it is formed, or of which it is a part. This sphere has its own center, and this sphere has its own center somewhere over here. But for the lens, now it has two centers, right? So we can't just leave it off like C and C. So I give two names like C1, C2. And here is this optical center. This is the principal axis that passes an imaginary straight line that passes through C1 optic center and C2. Alright. Now I'll go for focus, okay, or principal focus. Now principal focus is a point. Similarly, whatever you learnt in spherical mirrors, same kind of terms you're going to learn in spherical lenses too. But it's little different. Slight difference is there. Now first let me go with the convex lens. Then I'll teach you with the concave lens, okay? Convex lens, alright. This is the optic center, principal axis. Alright. Now some kind of parallel rays to the principal axis incident on this spherical lens. Parallel rays to the principal axis incident on my spherical lens. This is the convex lens, okay? First I take parallel rays. Somewhere from infinity these rays come an incident on the convex lens, and after refraction, I'll draw two rays. After refraction, meet at a point, somewhere at this point, and this refracted rays go somewhere at this point. Now this point is the principal focus. Alright, it is the principal focus. Now if the rays come from this way, if the rays incident this way, then after refraction, where will it go and meet? Somewhere here, right? It can refract anyway. Again, this is the F. So it has two focuses, okay? Two focus. So I take this as F1, F2. Okay, this point F1, this point F2. Then next I go for concave lenses. How it takes place in case of concave lenses. How is the focus in case of concave lens? This is a concave lens. Optic center. Then this principal axis. Wait. First let me draw this dotted lines so that the diagram becomes easier to understand. Incident rays parallel to the principal axis. After refraction, diverges. It diverges, okay? So goes like this. But it actually emerges from this point. Again, this ray goes like this, refracted like this, it's refracted like this, but actually emerges from this point. So I take this to be F1, because again we are going to have another focus over here. Alright, now let me take my incident rays somewhere from this way. Just imagine the incident rays come like somewhere like this. This is my incident ray, another incident ray. After divergence, what will happen? Goes like this, the refracted ray. This ray refracts like this, okay, but emerges from here, here, F2, okay. you can understand this F1, F2. So to focus. Now we have learned about the first let me draw a convex lens. We have learned optic center, then we learned center of curvature, right? Two center of curvature, C1, C2. Then we learned about focus, F1, F2. Now in spherical mirrors we had something called focal length, right? Even here we have something called focal length. That is the difference between the distance between the optic center and focus, the two focus. This is one focal length and this is the other focal length. Alright. Now this is your principal axis that passes all from these points. Alright. But in spherical lenses, while doing the ray diagrams or while doing the sums, we won't be taking the center of curvature because we don't have any kind of sphere here. Alright. This is only the lens, not sphere. In case of sphere, sphere definitely has a center. But since it is not a sphere, it's just part of a sphere, or for any other reason maybe, we don't take it as C1, C2. And we have already learnt in our previous videos like this equation, right? Radius of curvature is equal to twice the focal length. Now this distance in case of sphere, this is the radius, right? In case of sphere I am talking about. Even here it's like a radius, and we already know that twice the focal length is what? It is the radius of curvature. So instead of taking C1, C2, what we do is we implement this formula. So radius of curvature is twice the focal length, we have already learned. So instead of taking C1, C2, what we do is we write 2F1 and this is 2F2. Twice this is this and twice this is this. Same ways for concave lenses also. Alright, same thing for concave lens. This is a concave lens. Same thing happens. This is the optic center, F1, 2F1, F2, 2F2. Alright, and this is your principal axis. That's it for today. These were about the spherical lenses, what is spherical lens, terms related to spherical lenses. If you have any doubt, to ask me in the comment section, or if you cannot understand, then just tell me in the comment section, or if you want me to make a video on a particular topic from any subject or on a particular chapter from any subject, just do mention in the comment section. Thank you.